Well, hello, everyone. Welcome to Roger Reviews. I'd like to do sort of a special edition today. There was a recent letter to the editor called Matters Arising about the nanoplastics in the brain paper. Some of you may have noticed. And I want to go over that briefly, but I want to put it in context and talk about all the correspondences to the editor that have been done regarding pyrolysis, GC mass spec measurements of micro and nanoplastics in our body, and talk a little bit about how effective or ineffective they've been at guiding and shaping this area of research, and just a few thoughts at the end about some things that maybe could be done better. So I'm going to go over the letter to the editor about the brain paper first. So this was a recent publication. You're limited to two pages, so there's only so much you can do in 2 pages. I think I could probably write an entire textbook about the problems with this paper without getting repetitive, but they did a pretty good job, I think, with the space limitations they had. So they mentioned this lack of any blanks at all, including procedural and field blanks, and then matrix contamination, lack of polymer spiking experiments. There's no percent recoveries, limits of detection quantification, particle integrity. These are things that a lot of other papers in this area do. And they're really standard operating procedures for analytical method development that are absent in this paper. They also mentioned, this is the big one that has a lot of people talking, that the previous video went into in detail. Um, this interference by lipids that appear to be polyethylene in this experiment. It's also a big problem with polyvinyl chloride. And if you look throughout these papers, polyethylene and polyvinyl chloride are the two most prevalent claimed polymer types found using this method. And they're really just an interference. I use the analogy of someone hands you a glass of water and says, I think there's some corn syrup in it, and you taste it and it tastes sweet. You may think it's corn syrup, but you really don't know, because it could be sugar or sucralose or NutraSweet or any other sort of sweetener. And that's the big mistake that's kind of subtle that really plagues research in this area. And they go into that in detail in this letter. And then they briefly spoke about the blood-brain barrier, how that should keep out most of these particles. So the grams of nanoplastics in a brain is just not a biologically plausible level of contamination. And then they talked about, the trends, the data trends that they observe over time. The apparent increase in nanoplastics could be related to obesity. So the point is that plastic production is not the only thing that has changed over the last 5 years. There could be something else that's going on there. Now, I would have included something about reproducibility of replicates. This is a drum that I'm going to continue to bang. If you're doing method development, one of the things you really need to do is show that you can get the same answer twice. If you measure the same sample twice, can you get the same answer twice? If you can't, it's really not a useful analytical method. I mean, imagine if you're looking to make a purchase, and so you need to know whether you have enough funds in your bank account to make that purchase. And so you go online and you check your balance, and it says you have $635 in your bank account. And then you hit the refresh button, and then it says you have $7,355 in your bank account, right? one of those might be right, but it's really not useful information if every time you hit the refresh button, you get a different number. And that's essentially what's happening with, no one knows because people aren't even trying to do replicates. But you really need to establish that you can measure the same value twice before you start trusting anything about these measurements. Regarding the blood-brain barrier, I would have gone a little bit farther and pointed out that the the mass fractions in the relevant particle size that can get into the brain is incredibly small. As you get to smaller and smaller particles, the number fractions are large, the mass fractions are small, and so you're talking about parts per trillion probably of the total mass of micro nanoplastics to which we are exposed that can actually cross the blood-brain barrier and get into the brain. So, it's just completely unreasonable to think that we're going to get to the levels that were reported in this paper. So I just would have elaborated on that point about the blood-brain barrier a little bit. Obesity trends, I think that's along the right pathway. But believe it or not, obesity over the last 5 to 10 years has not changed that much in the United States. It went up quickly over those past several decades, but it's kind of stabilized over the last few years. And I think the more likely explanation is unsaturation levels, so the number of double bonds in the the fatty acids that we're now consuming. And I went into that in more detail in my previous videos. Well, I would have also mentioned the laboratory environment, their discipline in terms of avoiding contamination from the laboratory environment is substandard compared to all the other labs that I've seen that are doing this kind of research. So they really don't take the normal precautions that everyone else does to avoid contamination from the laboratory environment. And then the last thing, and I just noticed this recently, I wish I would have included it in my previous video because this is a big one. So the analysis mode, they use what's called single shot analysis. Double shot mode is a way to preheat the sample and get rid of a lot of smaller organic molecules that can act as false positives when you do your pyrolysis. So you may be asking the question, okay, so you've shown that there's this interference problem for polyethylene and polyvinyl chloride, but these guys find all kinds of polymers or claim to find all kinds of polymers and polymers types that other groups don't. And I think a big reason why is this, they are the only ones that use this single shot mode. They don't clean out all of the stray signals of their instrument before they do the pyrolysis experiment. And that's why they're getting, that's the likely reason why they're claiming to see all these other polymer types that no one else sees, because they're just simply not doing the proper analytical technique. So maybe that made sense to you, maybe it didn't, but let me just put it in a simpler way. There's essentially an option within the analytical method where you can kind of say, do you want to do this extra step to minimize false positives, or do you not want to do this extra step and maximize false positives? And what these guys did was they said, let's just maximize the false positives. And really, when you read these papers, it seems like their entire methodology is all about maximizing false positives. So it's not a surprise that they're claiming to see so much micro and nanoplastics. And again, this letter to the editor, this communication to the editor pointed out a lot of the ways that they're checking yes in that box. So what's been the result of this? And I'm going to show you graphs like this throughout. So the blue is the original publication. So almost 1,000 mentions in news articles, 372 citations. This Mendeley, this is how many scientists that read this paper online made a special note of it in their records to keep it available for future citation. So citations is how many times this paper has been cited in subsequent scientific publications. Mendeley is kind of a measure of interest by scientists. The news reports is a measure of interest by the public. And then in this case, there have been no policy decisions that have cited this paper as influential in determining policy. So you see the blue lines are quite extensive. This response, the matters arising, it's been cited twice already. A few people have noted it, and there have been 15 news mentions already. So it's very recent. So the fact that these numbers are small is probably not surprising. So let's take a look. So this is the brain. Original paper was published in February of 25. This response was just recently published. It was about a month ago from today. So it's not surprising that it hasn't gotten a lot of run yet. But let's take a look at a previous example. So this same research group from New Mexico published a similar study finding or claiming to see nanoplastics in testes last year in 2024, May of last year. And there was a letter to the editor about this that came out in October. So let's go through that. This is what we had before. And this letter to the editor about the testes covered almost all of these same things. It pointed out all of these faults in the procedures and analytical methods that this group uses when doing these sorts of studies. So this was really a pretty comprehensive list of faults with what they were doing. And let's just take a look at the kind of attentions that has gotten. So again, hearing about plastic in our balls, I mean, that really captures the public attention. So, over 500 news mentions for that, a number of scientific citations. Now, how about the response? It's been cited once. So this letter to the editor has been completely unnoticed. I only noticed it a few weeks ago. It's completely under the radar. It pointed out all of the problems, almost all of the problems with this group's procedures and methods and approaches, and no one noticed. So I think probably the research group that did this learned a valuable lesson from this experience, and that is we can continue to use these faulty approaches and faulty methods, and even if people point them out, it won't hurt us, right? And unfortunately, that was the case initially, and I'm hoping that the things are sort of coming to a head now, and that's not going to be the case moving forward. It reminds me a little bit of my own experience because this was now 3 years ago when that initial blood paper came out using the same method, and I wrote a letter to the editor about that one. I didn't point out all of these things because the blood paper actually did most of these things, and I was focused purely on the fact that their duplicate analyses did not match. And again, if you measure the same sample twice and get different answers, the method is not useful. And I also pointed out that the pattern of contamination was very consistent with an external contaminant, and it didn't make any sense at all for plastics actually in the blood. So I missed a big one, and the big one I missed was this internal interference problem. I wasn't thinking about that at all at the time. This letter has gotten a little bit of attention, so 39 citations. It was actually mentioned in the news 6 times. I've looked at some of those articles. They're not like The Guardian, right? It's not big, important publications, just little ones, but at least it did get a little bit of run. But, look at all the attention that the original paper has gotten. So 2,600 citations. It's been in the news over 1,000 times. And here's the crazy one. Look at policy. This paper has been cited 78 times in a policy decision. So this paper where they're unable to measure a sample and get the same number twice, proving that it's just a completely non-useful method, is not only shaping public opinion, shaping scientific opinion, but it's shaping policy. And the attempt to point out the flaws, yes, a few people noticed, but it's just not getting the effect that needs to happen. Now, believe it or not, there's a follow-up to this one as well, and this was mostly a different set of authors, but it was the same corresponding author, where they used essentially the same methodological approach to measure microplastics in blood again. There were a few cosmetic changes, but really the same overall problems are present, and there's no reason to believe the results of this study either. There was actually a letter to the editor published about this one already last year, and they didn't focus on these things that are really the most important ones. What they pointed out was, this kind of read to me like someone who's used to a method that works pretty well and they want it to work perfectly. So this was sort of fine tuning kinds of concerns that they had. Like, do the microplastic particles maintain their integrity throughout the um, isolation procedure? They brought up some esoteric concerns about identification in terms of like interference from other plastic types that are present, which again, that may eventually be an issue once you solve the larger problems. And then they did make some points about expected concentrations probably being lower. I would have framed that argument a little bit differently, and it's a valid argument. But it didn't really sink. I wish they would have mentioned again reproducibility. So the authors of this paper didn't have any issues with reproducibility because in this follow-up paper, they simply decided to only do single analyses. Okay, so there's no way to know whether the the second measurement of the same sample gives you the same answer because they didn't do a second measurement. Okay, so I that's just astounding to me that anyone could think that this is okay to do. If your original method is flawed because you can't get the same answer twice, and then you claim to have fixed that method and you don't even try to get the same answer twice, I mean, I just don't know how this gets published. I really don't. So that's how they address the problem of reproducibility, which is to say that they did not address the problem of reproducibility, and they don't do what really needs to be done to look at the interference problem, which is to look at the ratios of intensities of multiple signals as taught by Rauert in um, their groundbreaking paper that was discussed in the last video. They claim to address this problem of interference because their percent recoveries are close to what's expected. But that really isn't applicable. So that basically what they're saying is, if we go back to that glass of water, they say, it had a little sweet taste to it. We added some corn syrup to it, and it got sweeter, and it got the right amount sweeter, so there was no interference problem. Well, just because you add corn syrup to something and it gets sweeter doesn't mean that you know that the original sweetener in the water was corn syrup. If you've got water with sugar in it and you add corn syrup to it, it's still going to get sweeter. So they really didn't prove that they overcame this problem of interference. And in fact, it's almost certain that they still have a problem with interference. And of course, their main plastic types that they claim to find are polyethylene and polyvinyl chloride, which are known to be problematic in terms of interference. So this paper really only makes a few cosmetic advances on their previous report. It doesn't address the primary issues, which are laboratory contamination, which could be detected by replicate analysis, and interference problems which could be addressed as described by Raud et al. Now, this one is a little bit more interesting because the letter to the editor got 8 news mentions. And so you might say, well, that's good. Like the news is finally waking up to this. Well, not so much. If you look at what's printed in those news mentions, it's essentially the same text in all of them. And all of them say, despite this letter to the editor, the author's response addressed all of the issues, all of the potential problems with this method, and this method is now firmly established as completely reliable. So, I'm generally not a conspiracy theorist, but I don't know that this is a conspiracy, but this certainly seems to be a well-coordinated news response to this letter to the editor, which the letter to the editor really didn't get to the heart of the issue. And I guess we can only hope that at some point they decide that, um, they'd rather be scientifically accurate than continue to press this false narrative. But I don't know. I mean, I'm not a mind reader. I don't know what their motivations are, and I don't know what it would take to get them to that point. I think it's really hard. Once you sort of put your foot in the ground, um, your scientific reputation is going to take a hit regardless. I don't know if it's a political calculation or they still really believe that this method works. I don't know what's going on in their minds, but I really think in order to advance this field, you have to pull back on these things that don't work. Okay, we have to get rid of this idea that this method works for this type of an analysis so that the true research can move forward, so that the method development that needs to happen can happen. The resources can get allocated appropriately to get things happening the way they need to happen. Okay, there was one other one. There was one other letter to the editor worth mentioning. That was for Atheromas, which are arterial plaque. I also went over this one in an earlier video, but just briefly, the only thing that was mentioned in this letter was they didn't do any field blanks. There could be some matrix contamination, which is definitely true, and laboratory environment. So they were really focused on external contaminants. And to be fair, the way the New England Journal of Medicine works, you only have, I can't remember, it's like maybe 6 weeks or something. It's some really short period of time to write a letter to the editor because you can guess why I know that. By the time I read this article, that time period was already passed. So there's no mechanism that I know of at this point for any further correspondence. So within this brief period of time, knowing what they knew then, this is probably about the best they could do. But we know now the big problem here is um, the interference problem. But in this case, they also didn't do a lot of these sort of standard method development that should be done. And again, all they found here was polyethylene and polyvinyl chloride, which we know are due to interferences. So how well did this one do? Well, again, this is a paper that's, made a huge impact both scientifically and in the public. It even got quoted in one policy development, and the number of citations for this letter, the editor is 9. So the letter is really, no one's paying attention to the letter. So again, this, if you were a medical researcher, you're a doctor, you want to know about, are microplastics a potential problem for arterial plaque? You read this article, you would absolutely think the answer is yes, right? There's nothing there to make you think that there's anything wrong with this paper. And I don't know how you fix that, right? This paper is still published, it's still available, and without any other context, you would think that this is a valid article. Okay, so now I've gone over all of the correspondences to the editor that I'm aware of. within the field of pyrolysis GC mass spec measurements of plastic content in our bodies. There are a lot of other papers in this area that have not received any subsequent communication. In fact, there are more that have not been commented on than there are that have been commented on. You might be surprised how difficult it is to get a letter to the editor published. I think the editors don't really want to take the hit, right? It's not a good look for the journal to have papers published that are faulty. In a lot of cases, the authors of the original papers are their customers, right? They're paying ungodly amounts of money to get these papers published. And so, they don't want to piss off their customer. So the business model is a little bit messed up. And in fact, the entire scientific apparatus is not really well suited to respond to publications that are incorrect. They're supposed to be caught by peer review. Okay, so it should have been peer review keeping all of these articles from getting published in the first place. And for some reason, that's failing. Well, I should say peer review and also the author's own standards and internal reviews. How is it that you can have these huge groups in some cases of authors, and not a single one of them steps up and says, look, I just don't think this is right. Like the blood paper. How is it that entire list of authors, none of them said, look, we can't publish this. These results are not reproducible. We can't measure the same thing twice. We can't publish this. I don't know if people are just afraid to speak up and it's really one person at the top making all these decisions and they're not willing to listen to anybody beneath them. I don't know. But, these things need to get caught before publication because the scientific apparatus for dealing with them once they get published is really bad. It's really hard to say, no, 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 just kidding. This is wrong. It's failing. Now, the one good thing is this paper, which again was the subject of the previous video that came out in January of this year, pointed out the flaws in all of these on the bottom. And so I would hope that moving forward, people recognize that this paper, this third one about the blood that says, no, it's all interference. We can't really measure it. It's below range. We can't get reproducible results. This method doesn't work for this. It probably doesn't work for any of these other things. That's the one that needs to get referenced. That's the one that needs to get read. And that's the one that needs to be recognized as the true pioneering research in this area. All the rest of this stuff is garbage, okay? None of it means anything. All of these papers down here really don't have any scientific value at all. So if you add up all of this, these are citations, Mendeley, and news reports for all of the ones that in black on the previous slide. And then the one at the bottom, this is the blood paper that gets things correct. How can that be so low? I mean, how can it be that this is getting so little attention? This is the only paper in this area that is really doing the methodology right. This one really needs to be recognized as the true important paper in this area. So hopefully this number here, this 31, should be about 10 times all of the rest of these put together. And hopefully we'll get to that. So the grand total, if you add all of these things together, the faulty reports compared to the corrections and the one correct report in this area, this is the impact of this method applied to human tissues and fluids. Scientific publications are 98% misinformed. Scientists themselves, the same number, 98% misinformed. The public is 99% misinformed, so the news reporting in this area is 99% based on incorrect information, and public policy is 100% misinformed. So that's been the impact of this method being incorrectly applied in this area. So it just makes me think of this quote from The Man Who Shot Liberty Valance. I did watch this. It's a great movie. It's in black and white. No, I did not watch it when it first came out. Um, and this is a line at the end: when the legend becomes fact, print the legend. So I don't remember the storyline that well, but there's some sort of reporter looking into this gunfight, and there's a hero, a local hero, who allegedly is the one who shot the bad guy. Well, when you get down to it, it turns out that's not what really happened. But the reporter decides that he's going to print the legend anyway, because he just thinks it's a better story, and maybe it's better for everyone if everyone continues to believe that this hero is the one who actually killed the bad guy. The news media a lot of times tell us the legend, not the fact. They tell us what they think we want to hear and not necessarily what is true. And we just can't allow this to infiltrate science as well. And I am concerned that that's what's happening, especially when you look at what the metrics are for evaluating the impact of a scientific article. So if you look at these things like news mentions and you use that to judge the success of a scientific report, well, that's like a social media thing. That's like, how many likes does it get? Well, if you go to any sort of social media, I don't care, LinkedIn, Facebook, Reddit, whatever, the success of a post is determined by how many people like the post, right? It doesn't have anything to do with whether it's true or not. And that, I'm worried, is starting to infiltrate science. Science should not be judged based on whether people like it. And I know a lot of people really like the idea of having a spoon in their brains, right? It's crazy. Like, everyone's talking about it. Everybody's going nuts about it. Everyone's worried about it. So I can see why people think that's an important article. Well, it's wrong. So, scientifically it has no value, but in terms of social media fodder, it has a lot of value. And we just can't let science be judged on likes, and I'm worried that's the direction that we're going. And I think I'm not the only one. So I wanted to just show you this quote from that first letter about the brain. This is the lead author. I don't know who actually wrote this part of the article. Findings that lack adequate validation may inadvertently shape public perception and regulatory discussions despite underlying scientific uncertainties. That's ringing an alarm bell, saying, hey guys, you're messing this up and people are believing you, and you're having an impact on society and policy, and it's wrong. So, the science is important. We need to get it right. And this is a pretty strong statement to come in a scientific publication, which is generally pretty conservative about that kind of thing. And then the other one was what Cassie mentioned in the previous video, and I'm just quoting from that previous video, where she says it's irresponsible as scientists. We want to be able to get the data right so we can properly inform our health agencies, our government, and the general population. And so I think everyone's starting to recognize this is an issue. I'm hoping that it's constrained more or less to this one sort of subsection of, this one method used within our bodies, but it's been a big impact. I mean, those are big numbers in terms of citations, and even public policy being shaped by these faulty publications. So what to do about it? The only thing I can think of is to make the peer review process better. So this is kind of third on the list of what I hear, uh, academicians complaining about. There's this problem with artificial intelligence. Uh, so many scientific articles now are getting submitted that were generated by AI, and I know that is a real problem. There's concerns about getting overloaded with too many peer reviews to do, because of this sort of dilution effect, the publish or perish thing. So now everyone is trying to publish everything. And so there is a general overall decrease in quality of publication and an overload of peer review needed. And I think that's a real problem too. Probably this problem of substandard publications getting pushed through is maybe just a subset of those larger problems. But in this particular instance, especially for microplastics and nanoplastics, one of the things that I would recommend, which could alleviate some of that earlier problem, is if editors would ask for peer reviews from people motivated to find concerns with the publications, that would benefit the quality of the final product, the final publication. In this case, I would just go to scientists who publish within the plastics industry. Okay. And there are plenty of scientists who are publishing papers that come from the plastics industry who are quite capable and probably willing to review these reports. Now, I know some people, your initial thought would be, that's just crazy. There's no way these guys would accept these publications. They're just going to try to find every kind of problem with it. And that's just unfair to the scientists submitting the paper. Well, I would push back on that, because keep in mind that the peer reviewers do not determine whether a paper gets published. The editor determines that. And if the editor looks at a peer review feedback and says, this is a bunch of nonsense, these guys are just making stuff up, this has nothing to do with the paper, they can just ignore that peer review. So the peer reviewers are required to provide scientifically valid feedback. Okay. And if you were to go to scientists who are perhaps motivated to find flaws in the articles, at least you would weed out some of the papers that have insufficient evidence to support their conclusions, like we've just gone over. So I really think that would also alleviate some of the overload that the academic scientists are feeling in terms of getting too many papers to peer review. So that's the one thing, is that it's the editor who makes the decision. The other thing I would point out is you may be surprised at how fair and honest and scientifically valid the scientists from industry are in their peer reviews. I peer reviewed a lot of papers. I don't publish much anymore, so I don't get. You have to publish in order to be eligible to peer review. I don't publish anymore, so the peer reviews I do now are what you see in these videos. But I think my percentages were probably about the same overall. I rarely said publish without change. A lot of times I asked for minor revisions, a lot of times major revisions. Occasionally I would say, this isn't the appropriate journal. And then I think I had maybe one the whole time where I said just reject, because they just don't get it. But I think you'll find that scientists working in industry are scientists, and their primary motivation is to get the science right, just like the primary motivation of most scientists in academia. So that would be my one suggestion that could help, at least within this area of research. Okay, I really am trying to move on from this topic. I think I've finally said about all I need to say. I am optimistic. So this onslaught of papers using this method and getting faulty results seems to have slowed significantly. Most of the papers I'm seeing now are more boring and more accurate. And so that's the good news. I don't know that I can really do much else here. So there are some other topics related to microplastics that I find interesting, and the science is better. And I suspect that that's the direction I'm going to head after that. So I guess I'll just say thanks for watching, and there's probably more to come.